Alright, this is an integration by substitution, and the first thing I do is remember typically you're going to substitute what's under a square root, and this works out real nicely if you let u equal 3 times 2r minus 1 squared plus 6. And the reason this works out so nicely is so now my du equals 3 times 2, so I'm doing the chain rule here. I'm going to bring the 2 down, so 3 times 2, leave the inside alone, subtract 1 from the exponent, so that's just the first power, and then times the derivative of what's inside, which is 2, because the derivative of 2r is 2. And then the derivative of a constant, of course, is 0, so then dr. I can make this look a little better. 3 times 2 times 2 is 12, 2r minus 1 dr. And now I kind of look up here and I say, well, that certainly would be nice if it didn't have that stinking 12 in front of it. So no problem. We can divide the 12 du 2r minus 1 dr. Alright, so the problem is though is we still have all this square root business going on, so we'd even like to do some more substitution where we could let v equal the square root of u. Alright, I mean that's kind of nice because this is u up here, and now we just have to plug in square root, and instead of all that mess, just u. Well then of course dv equals 1 over 2 square root u du. Again, looking here, I say, man, that would be nice if that was a 12. Well, I could do that. I can multiply both sides by 1/6. So I get 1 over 12 square root u du. I think you're going to see, you know, all this, man, that would be nice, that would be nice. I think you're going to see the why when we start plugging all this stuff back in. Okay, so we have this whole u business going on that we're going to plug in, and then we need this in terms of du, and that was this whole mess here, so we're going to plug this in. So let's go back. This is going to be difficult to see all this at once, but I'm going to plug in, so where I see 2r minus 1 dr, let's just rewrite all this again so you can see it. So 2r minus 1 cosine of 3 times 2r minus 1 squared plus 6 all over the square root of 3 times 2r minus 1 squared plus 6. So let's see where all these pieces are coming from. So certainly you can see that's going to become u, and that's going to become u. So that's probably pretty easy to see right away that those are going to become u's. So I'm going to have cosine of square root of u over the square root of u. Well, this piece right here, and let me write my dr out here, this piece and this piece, if you notice, is this. So that becomes the 1/12 du. So I end up with cosine square root u over square root u times 1/12 du. Alright, so now the problem is we're kind of, if you remember back here, I said it'd be nice to get rid of that square root, so we're actually going to rewrite this as cosine of v. Okay, now notice though, if I go back and I look at my, in terms of v, I have 1/12 square root u. So this piece right here is going to become 1/6 dv, which makes sense. This has to all be in terms of the same variable. I mean, again, this is kind of messy and hard to see, but that's all we're doing. And so now it makes this easy to do. Well, this is just going to become 1/6 cosine v dv, which is easy to find the antiderivative, which is just the sine, and then of course plus c. And now we go backwards, and again, this would be really nice if you could see all this on one screen, but we go backwards and we start plugging things in. V is the square root of u, so I get 1/6 sine square root of u plus c, and then 1/6 sine, and go way back up here, and remember what u was, so we plug that back in down here, so we end up with the square root, and u was 3 times 2r minus 1 squared plus 6, and then of course somewhere out there plus c. So I mean, the big key here was to first recognize that you wanted to take the 3 times 2r minus 1 squared plus 6, make that your u, take the derivative of it, make it look like what's left over. What was left over? 2r minus 1 dr. So we did. We had to divide out of 12. And then we also did a second substitution and said, well, let v equal the square root of u. So that makes it easy to write, cosine square root of u over square root of u. Took the derivative of that, and now we wanted to make this side look just like this, 1/12. So we had to multiply both sides by 1/6, and then away we went, plugging everything back in. Hopefully that wasn't too confusing, and I think if you not just sit here and stare and watch me do it, if you actually write it and pause it, and that way you could see it all on one sheet of paper. I just can't write small enough so you can kind of see where I'm jumping from step to step. But I hope that helps.